Welcome to this live. We're going to discuss this paper. So will you upload the predictions? Okay, let's see. I can see a question being asked here by Iram. Iram, which prediction are you talking about? Which prediction is, especially which subjects and which level, so that I can be able to know exactly what you mean. All right, so basically I want to bring to your attention here, we are supposed to talk about physics year 11, that is Igcse. So you can see I'm having one of the most recent past paper. This is Igcse physics. Guys, if you are new to Proflan, consider subscribing. So what you need to notice is that you'll be provided with the formulas in the first page, and sometimes I've seen them providing formula booklets. So this is that you really need to look at, the first part that you must check, because these formulas will enable you to answer most of the questions that are inside the paper. Looking at question 1, and you can leave also a comment in the chat section. That is pure math 1 AS Edexcel. Yeah, all right, that one today is on Saturday. By tomorrow, Ram, you're gonna get it. Maybe in the evening I'll be uploading it, because I know that paper is coming soon. So probably by tomorrow evening you'll see the prediction for that. Right, okay, so the first question that is being tested here is how the orbit of different celestial objects appear, especially if we are talking about the orbit of the moon. Usually the moon orbit around the earth, while the earth or planets, they orbit around the sun. So we were supposed to draw the orbit of the moon here, and that is exactly what you are supposed to take note of. Need also to remember that the orbit of the moon is usually circular, but planet, they have elliptical orbits. Okay, I hope there is no question on that part. And then we need to talk about the force that keeps the moon around its orbit. That's gravitational force, and it's usually acts towards the moon is pulled toward the center of the earth, so it keeps on orbiting around. Well, then we need to move to the next question here. The next question talks about the name of another object that orbits the earth. Another object that orbits the earth is usually satellites and space stations. Yeah, satellite and space stations, they usually orbit around the earth. Yes. And on this section also I've tried to draw different orbit. The orbit of a planet, that is a planet, they orbit around the sun, and we have another object that orbits the sun, which is the comet. But you can see the shape of a comet is such that it's quite elongated, quite stretched, quite elliptical. So the sun is usually towards one end of the orbit. So something else that you need to understand as far as the exam is concerned is that the speed of the comet vary depending on the position. When it's closest here, it will be moving at a very, very high speed. When it's somewhere here, to be moving slowly. So the orbit of a comet is more elliptical than that of the Earth, and but the similarity between the orbit of a comet and the orbit of a planet is that both of them they orbit around the sun. Yeah, so both of them they orbit around the sun, but the shape is the one that now determines the difference between the two. Is there any question on that area? So once we have identified that, the differences between the two, and you can see we have talked about orbit of the moon, it orbits around the Earth, and something also that you need to remember is about orbital speed. Yeah, orbital speed is the speed at which a body is orbiting around the Earth, or the speed at which the Earth orbits around the sun. So it's usually 2 pi r, whereby r is the radius of the orbit over the time period, and time period is the time it takes the orbit to go around. So you need to remember this formula as well, as much as you are going to sit for that exam. Remember that the force that keep these particular objects to move around the sun or the moon moving around the Earth, the force is gravitational force. Another object that orbits the Earth is a satellite or a space station. So you need also to understand the difference between the orbit of a comet and orbit of a planet, which are around the star. Remember also what are the similarities between orbit of a comet and orbit of a planet. Basically, that is it. We need to look at question number 2, and question number 2 we are told is a question about radioactivity. So it's a question about radioactivity, so which means that we need to know how to ask a question to do with radioactivity. So remember that if we are having this as a symbol for an element, the top number represents the mass number, and this bottom number represents the atomic number. Atomic number is the number of protons, but mass number is the protons plus neutrons. So in this case here, we can be able to identify isotopes. Isotopes, they must have some same number of protons but different mass numbers. So in this case, you are told which row of the table shows the nucleus of an atom that is different isotope from carbon. So this was 6 and 8. So we have 6 protons, 8 neutrons. 6 protons, 8 neutrons. So which means number of neutron here. The number of neutrons, number of protons, number of neutrons. So it has to be this. It has to be A, because for isotopes they must have the same number of protons but different number of neutrons. There are 3 types of radiation that can be given by radioactive isotopes, and those radiations, they include alpha, beta, and gamma. So if you are asked high energy electron, those are beta. Those are fast moving electrons. Beta are fast moving electrons. Helium, they represent alpha, and those that are electromagnetic, yeah, waves. Those that are electromagnetic waves, they are usually gamma radiations. Gamma radiations are usually electromagnetic waves. Question part C. The nucleus emits radiation. This causes the mass number to decrease by 1 and the atomic number stays the same. So how are we going to identify that? The first thing that you need to realize is that if we have identified a neutron emission as 1, 0, so it means that if you are having, for instance, an element X which has 28, I'm just giving an example, and atomic number of 5. So if it's emitting a neutron, it means we are told the mass number to decrease by 1, atomic number to remain the same. So which means the element will remain the same element, atomic number will remain the same, but if it's emitting a neutron, so we shall have 1 0 here. So we need to balance now. What number should we have at this given point? Just leave a comment in the in the comment section. Which kind of value are we going to have here, so that we can balance with this one? Just leave a comment in the comment section. So that's why we are going to say the neutron. Can you check whether you got it right? This is going to be 27. So that 27 plus 1 is going to give us 28. Yeah. Nucleus of an isotope of uranium can be represented using this symbol. And then how many electrons will this be in an ion? Positively charged. So that's going to be 90 in that case. Then moving to E. A radioactive isotope has an initial activity of 400. Half-life. What is half-life? So something that also you need to remember is to define what an half-life is, because you may be asked that. Half-life. What's half-life? How do you define half-life? Just write in the comment section. Yes, in the chat, in the live chat text there, right? What do we mean by half-life? You know, what is half-life? What's half-life, guys? What's half-life? So this is going to be, half-life is the time taken for the activity of a radioactive substance to decrease by half. So if we are having, for instance, 400 here, we are having 400. How long does it take the activity to decrease to 200? That time it takes the activity to decrease to 200, that is what we call half-life. Half-life is the time taken for the activity of a radioactive substance to decrease by a half. Yes. So if it is 400, it will take a period of time. So if we're given the half-life being 8, in this question the half-life is 8, isn't it? So if the half-life is 8, in 16 hours, how many half-life do we have? That's another question that you need to ask yourself. How many half-life do we have in 16 hours? That is 16 divided by 8. And if you divide that, you are going to get 2 half-life. So which means this radioisotope is going to decay 2 times. So from 400, it becomes 200. Half of 200 become 100. So after 2 half-life, the activity is 100 becquerel. So another way questions will be asked in this section in your coming May-June exam is that if you are having a graph, maybe they are going to test you on a graph pattern, because we have to ensure that you have prepared for everything. So if you have a graph that is like that, and basically you are supposed to work out half-life. If this is 500 becquerel, then you need to check if they are asking you half-life. Of course, we shall have time here, and this is the activity. This is the activity on this scale in becquerel, in BQ. So if you want to find half-life, you divide this value by 2. You come and check what is 250. What is 250? 50. So in this case, 250 is going to be somewhere here. Then you are going to and it's going to, we are going to draw a straight line. We check where it meet, we meet the graph, and then we read the value down here. This is going to be our half-life. The value that you'll have down here is going to be our half-life. So basically that's what you are supposed to do in that particular question. Another topic that you really need to prepare is the topic of electromagnetic spectrum, EM waves, electromagnetic spectrum waves, EM waves. EM waves. So under EM waves, you need to know that EM waves, electromagnetic waves, are a family of waves which are arranged in the order of increasing frequency or decreasing frequency, or increasing wavelength or decreasing wavelength. So there is a family of and then you need to understand their characteristics, common properties. Under the common properties, we can say all of them are transverse in nature. All of them, they are transverse in nature. All of them, they travel at the speed of light. You need to understand that all of them, they travel at the speed of light. You need to understand that all of them, they undergo reflection, they undergo refraction, they undergo diffraction, because they are all electromagnetic waves. All of them, they obey the wave equation. Gamma rays, they can cause cancer, isn't it? Differences is based on wavelength and frequency. Don't give differences based on the uses. Yeah, so you need to remember that. So in this case, the question was testing the concept of time and speed, whereby an infrared heating lamp are placed 1.5 meters from the car. Calculate the time taken for the infrared wave to travel emitted from the lamp to reach the car. So we are given the speed at which it travels, so we can say that speed is equals to distance over time, and we can be able to say time is going to be t equals to 1.5 over 3 times 10 to the power 8, and our answer becomes 5 times 10 to the power 19.